Assalamualaikum warahmatullahi wabarakatuh. So today we will try to solve question number 5 from the past year October 2012. So we'll go into understanding the question first. The shaft assembly shown in figure below. So this is the shaft assembly, as you can see, used to transmit power from electric motors by means of flat belt drive to various machines. So this shaft assembly is powered by electric motor. The pulley A, so this is pulley A, pulley B, this is pulley B, pulley C, this is pulley C, and pulley D, so this is pulley D, and the bearings 1, 2, so this is the first bearing, number 1, and then this is the second bearing, number 2, are located as shown in figure below. So this is the configuration of pulley A, B, C, and D, and then this is the bearing number 1 and then bearing number 2. The pulley A of diameter 500 mm. So given that pulley A, the diameter of pulley A is 500 mm. So we will write all the information given. So data, the information first is pulley A, where given that the diameter of pulley A is 500 mm. Then this pulley is driven by vertical belt from motor pulley at 900 revolution per minute. Means that pulley A receive power from motor. So pulley A receive power from motor, means that on this shaft assembly here, pulley A will become the driver pulley because pulley A receive power from motor outside of this shaft assembly. So pulley A will be assumed as the driver pulley. So pulley A is the driver pulley. And then given that the speed of the pulley is equal to 900 revolution per minute. The motor supplied power 18.7 kilowatt to the pulley A. So the value of power given to the pulley A from the motor is equal to 18.7 kilowatt power. So power at pulley A is 18.7 kilowatt. And then a belt from pulley B drives a machine tool at angle 70 degree. So this is pulley B, and then this pulley B have this belt here, and as you can see, this is the direction of the belt of pulley B. Okay, and then this belt, it says that the belt will drive a machine tool at angle of 70 degree from vertical. Means that so let's say for pulley B, okay, so this is the driven pulley. So why this pulley B is the driven pulley for this shaft assembly? Because power is given from motor to the pulley A, and then power that comes from the pulley A will be distributed to pulley B, distribute to pulley C, and also distribute to pulley D. Means that pulley B, pulley C, and pulley D will become the driven pulley. So the angle of the belt from pulley B is 70 degree from the vertical. So if we imagine, let's say this is the pulley B, and as you can see, the belt is the direction of belt for pulley B, like this one. Okay, so we draw like this. Okay, TB, and then another one is here, TB. So the angle of this belt, okay, it says that the angle is 70 degree from the vertical. So this is 70 degree from the vertical. Okay, and then another belt from pulley C. So this is the pulley C, and then we can see that the direction of belt for pulley C, this one, acting on the right downward here, as you can see here. So another belt from pulley C, so this is the pulley C here, drives a grinder of 60 degree from vertical. So also for pulley C, let's say this is the pulley C, then we know that the direction of belt for pulley C, like this one. So we draw, okay, so this will become TC, and then the direction of pulley C is 60 degree from the vertical. So let's say this is the vertical like this, and then this will become the degree, which is 60 degree. Okay, now and belt from pulley D, so this is the pulley D here, then pulley D, this one is pulley D, this one, okay, and that, so this is the direction of the belt for pulley D, horizontal on the right side. Okay, so if we draw the Fibonacci diagram of the pulley D, so it will become like this. Okay, so let's say this is pulley D, and then as you can see, for pulley B, for pulley D, the direction is horizontal to the right side. Okay, horizontal to the right side. So this is DD. So I hope you can imagine the direction of each belt for pulley. So for pulley B, the direction of belt is acting on the left side downside, which is 70 degree to the vertical, and then for pulley C, acting on the downside to the right side, like this one, as you can see here, and then the angle of the belt is 60 degree from vertical. So this is the vertical, and then 60 degree to the vertical. And then for pulley D, you can see that from this diagram, the direction of belt for pulley D is horizontal to the right side. And then for pulley A, from this diagram, we know that the direction of belt for pulley A is acting vertical downwards. So if we draw for pulley A, so this is pulley A, and then this is the direction of belt for pulley A, which is acting on the vertical downwards. And then given also the belt tension ratio for all pulley is 2, means that let's say T1 is the tight side, okay, tight side, and then T2 is the flex side. So belt tension ratio means that if the tight side is equal to 2 T2 on the tension on the flex side, and then we assume that the factor of safety is 2, so factor of safety for the shaft is equal to 2. Okay, to 2, and is made from the material of STM A242. So what the question want us to find? So the first one is to sketch the shear force and bending moment diagram. So they want us to find the shear force, shear force diagram and bending moment diagram. And then the second one is to know what is the size. So the size means that the diameter of the shaft. Also given that here there is a table, there is a machine which is a pulley that drives the machine. For pulley B drives the machine too with speed of 400 revolution per minute and power is 9.3 kilowatt, and then the diameter of pulley B is 400 millimeter. And then for pulley C here, so for pulley C, it drives the grinder with the speed of 300 revolution per minute, and then given power is 3.4 to drive the grinder, and then the diameter of pulley C is 350 millimeter. And then the last one, we have the pulley D here. So this pulley D is designed to drive the dust extractor with a speed of 500 revolution per minute, and then given the power to drive the dust extractor is 6 kilowatt, and then the diameter of pulley D is 440 millimeter. So now we will try to solve question number A, which is sketch the shear force and bending moment diagram. So before we can sketch the shear force and bending moment diagram, first we need to know the direction of force and its value for this assembly of shaft, because as you can see from this figure here, this force is the combination of horizontal and vertical with the inclined angle above. So it means that we need to resolve this force into x and y component. So let's say for x-axis, so let's say this is the shaft, this is A, bearing number 1, C, this is B, pulley B, this is pulley C, and then this is bearing number 2, and then this is pulley D, and then for y-axis, bearing A, pulley A, bearing 1, pulley B, pulley C, then we have bearing number 2, and then we have pulley D. So first we need to know what is the value of this force here, tension on TD upper and TD down, because we need to know the load, so we can put this loading into the x-axis or into the y-axis with respect to the direction of forces here. Let's say, as you can see for pulley D, the belt direction is on the horizontal, means that for x-axis, for pulley D, there will be a load here, there will be a tension here or value of load force, but for y-axis, for pulley D, there will be no load acting on pulley D for y-axis, because we can see here the belt is in horizontal. Let's say we look into the pulley A. So this pulley A, the force is in terms of vertical or y-axis. So it means that for pulley A, for the x-axis, there will be no force acting on this point here, but for y-axis there will be a force acting at point A, because we know that the direction of belt for pulley A is vertical. But for pulley B and pulley C, pulley B, the belt have the inclined angle. So it means that for pulley B, we need to resolve this tension at pulley B into the y-axis, into the x-axis and y-axis. So it means that for pulley B, there will be a value in terms of x-axis and there will be a value tension in terms of y-axis, because we have resolved tension at B into the x-axis horizontal, into the y-axis vertical. So same goes for the pulley C, because as you can see for pulley C, the belt is acting on the right downside. It have the angle here. So for TC here, we need to resolve also into the x-axis and y-axis. So it means that for the position of pulley C, for x-axis and y-axis, it will have loading both in x-axis and y-axis, because we have resolved this TC into x and y. So the first step that we need to find is what is the value of A in terms of x and A in terms of y, and then what is the value of B, loading at B in terms of x and y, value of loading at point C in terms of x and y, and then what is the value of tension in terms for pulley D in terms of x and y, whether it have the value or not. So we need to calculate the total force or the total tension acting for each pulley here. So now we will try to find what is the total force of pulley A. As you can see from here, this is pulley A, and then if we draw the straight line here, so it is the represent this the pulley. Okay, so we draw for pulley A. So this is pulley A, and then the direction of belt for pulley A is acting on the vertical downwards. So acting on the vertical downwards. But for this question, I will use F1 as the tight side and F2 for the slack side. So means that this one I will change into, let's say, F1, and then this one I will change into slack side, because I want you not confused with the term T and F. So T here means the tension, not torsion. So in order to ensure that you will not confuse, I will change the TA into F. So we know F is tension or force. Okay. So the value of tension here, we can get the value from the equation of torque, which is torque is equal to Fr, or torque is equal to F1 minus F2 times with the radius of the pulley. Okay, so if you know the value of torque here, you can get the value of tension on the slack side, tight side, and tension on the slack side. Yeah, because we have another clue here. So another hint or clue is the belt tension ratio for all pulley is 2. Means that if F1 is the tight side, so tight side will equal to 2 times with the slack side. So this is the hint for this bulk tension ratio. So this is the equation number 1. And then from this will become your second equation. So if you solve equation number 1 and you solve equation number 2, you will get the value F1 and F2. We know that power acting on pulley A is equal to 18.7 kilowatt. So from this power we can get the value of torque. So by using formula P is equal to T omega, and then we arrange this formula. We want to make the torque as a equation. So T is equal to P divided by W. So we need to find what is the torque at pulley A is equal to. So given that power for pulley A is 18.7 kilowatt. So P divided by W. So value of power is 18.7 kilo divided by 2 pi, and the speed of the pulley A is 900 revolution per minute. So 900 revolution per minute divided by 60 to change into the second. So at the end we will get the value for torque at pulley A is 198.413 Newton meter. So this is the value for torque at pulley A, which is 198.413 Newton meter. So now we have the value of torque at pulley A, so we can put this value into this equation number 2 here. So we put the value here. So 198.413 is equal to F1 minus F2 times with the radius of pulley A. So we know the radius for pulley A is 500 millimeter. Convert to meter and then divided by 2 to get its radius. And then we have this another equation here. So we can put this value here to change, put inside this. So the equation will become 198.413 is equal to so when you change, so F1 will become 2, F2 minus F2 divided by 250 power of -3 because we change into the meter, and then we can solve for F2. So F2 you will get the value of F2 is around 0.0.794 kilonewton. Okay, and then this value of F2 here we put back into equation number 1. So you will get the value of F1, which is the tight side, is 2 times with 0.79 kilo, and then so F1 will become 1.588 kilonewton. So this is tension on the tight side, here, and then F2 is the tension on the flex side. Okay, so this is the value of so this is the value of tight side, and then this is this is the value of flex side, and then this is the value of tight side. So after we manage to find the value of tight side and slack side for pulley A, now we can get what is the total force acting at pulley A? So the value for F1 is equal to 1.5 at kilonewton, and the value for F2 here is 0.794 kilonewton. So what is the total force acting at pulley A? So this is the total force. So the total force is F1 plus with F2. So F1 plus with F2, the tight side, this tight side, which is 1.5 at kilonewton, times with F2, which is 0.794 kilonewton. So the value of this total force acting on pulley A, acting on the downwards. So the value is we assume it's force Fa is equal to 2.3 at 2 kilonewton. Okay. So this is the total force acting at pulley A, but the force is acting on the vertical one, vertical. So it acts on the vertical. So if I write back, so Fa force, the total force acting at pulley A is 2.3 at 2 kilonewton acting on downwards. So if we put the value of total force, which is Fa, on the free body diagram on the x-axis and y-axis, so this value of force acting at pulley A only have for the y-axis. Okay, for the y-axis, but for the x-axis there is no value or force acting at point A, because why there is no force acting at point A here? Because as you can see before, the value of total force of A, pulley A, acting on the vertical downside. So this is the pulley A here for y-axis. So there will be a force here. So this is the force Fa is equal to 2.3 at 2 kilonewton. But for point A, for x-axis, there is no force acting for x-axis, because this Fa, the force acting at pulley A, the total force acting at pulley A is only on the y-axis. So now let us consider force B here. Okay, force B. So in order to find what is the force, total force acting on pulley B, whether on the y-axis or x-axis, so we need to look into the pulley B here. So pulley B. Yeah. So this pulley B have inclined angle. The tension or the belt have the inclined angle. So we will resolve the force at point B, at pulley B, into x-axis and y-axis. So now for pulley B, so if we see the direction of belt for pulley B is on the downside, on the left side. So we draw the pulley B just for us to know the direction of pulley B. So this is tension of pulley B. Okay, tension of pulley B, and then it says that the angle of pulley B is 70 degree from the vertical. 70 degree from the vertical. So let's say this is the vertical line. So the angle of this tension for pulley B to the vertical is 70 degree. Okay, 70 degree. So that is the understanding here. So now, first, same like before, from pulley A, we will try to find what is the torque at pulley B. So we know that power for pulley B given is 9.3 kilowatt. So 9.3 kilowatt, and then the speed for pulley B is 400 revolution per minute. 400 revolution per minute. So from these two value, we can get what is the value of torque at pulley B. So formula of power T omega. So we erase back. We want to find what is the value of torque at pulley B. So PB divided by NB. So power at pulley B is 9.3 kilo, and then the speed is 2 pi times with 400 revolution per minute divided by 60 to change into the second. So torque at pulley B, we will get the value of torque for pulley B is 2.021 Newton meter. So this is the value for torque at pulley B. So now we managed to find what is the torque at pulley B. Next, we will try to find the tension at PB here and this one. But I will assume that this is F1 and this is F2. So F1 is for the tight side and F2 is for the slack side. So I will assume that F1 is equal to TB here, and then F2 is equal to TB here. And then we know that the bulk tension ratio is 2. So means that if F1 is the tight side and then F2 is the slack side, so tension, if the bulk tension ratio is 2, so tight side F1 is equal to 2 times with the slack side. So this one will become the first equation. Okay, the first equation. So now we know that from formula torque is equal to Fr. So if torque at pulley B is equal to is F1 minus F2, we can so F1 minus F2 times with RB. So given that we know that the value of torque at pulley B is 2.021 is equal to, so this F1 here we will put into this equation here. So F1 we change into 2F2. So 2F2 minus F2, and then radius for pulley B given previously is 400 millimeter, convert to meter, divided by 2. We want to use radius only. So we solve for F2, we will get the value of F2 is around 1.11 kilonewton. So this is the value for tension on the slack side for pulley B here. So next we want to find what is the value for the tight side. So we just use this formula. This formula is equal to F1 minus, if F1 equal to F2, so we put the value of F2 here into this, the first equation here. So we get F1 2 times with F2, so 2 times with 1.11 kilonewton. So F1 is equal to 2.22 kilonewton. So this is uh, the value of tension dioxide for pulley B, and then F2 is the value for tension on the slack side. So what is the total force acting at pulley B? Force which acting, so the total force which acting on pulley B here, so the total force of FB is equal to F1 plus with F2 here. So F1 plus with F2, we will get the value of so this is F1 here, we put value here, and then for F2, so we will get the value of the force acting at pulley B is around 3.33 kilonewton. Okay. So we know that from this figure here, the direction of this force, F, an inclined angle of 70 degree to vertical. So we need to resolve into the X and Y component. So for the X axis, so it become 3.33 kilo times with sine 70 degree, and then for the vertical, so 3.33 kilo times with cos 70 degree. Okay, so for 70 degree, so the value is 3129.1 at kilonewton for the x-axis, and then for the vertical it will become 1138.93 kilonewton. So what we will do from this value that we get, so this is for the x-axis of FB, and then this is for y-axis for FB. So we will put this value of tension at pulley B on x-axis and on y-axis on the free body diagram previously, which is, sorry, this is not kilonewton but only newton, and then this is also not kilonewton but sorry, newton. So for pulley B, for x-axis, we get the value acting on the left side, so it will become negative downwards with the value of 3129.18 kilonewton. And then for the y-axis for pulley B, because after we resolve, it acting on the left side x-axis and downwards for y-axis, so it will become negative here. Okay, so the value is 1138.91 kilonewton. Sorry, 93 kilonewton. So sorry, 1138.93 kilonewton. So this is the value that we get, total force acting at point B, after we resolve into X and into Y component. Next, we will try to find what is the force acting at pulley C for x-axis and y-axis, because if we see from this diagram, belt for policy also have inclined angle to the right downside. So it means that we will result into y-axis and x-axis. So it means that for policy here, in terms of x-axis, there will be a value force, and then also for policy here, policy for y-axis, it also have value. So sorry, not kilometer but Newton, and this is also same, but not kilometer but Newton. So now we will solve for policy to find what is the total force acting at pulley C. Okay. So from this diagram, as you can see, this is the pulley C, and then the direction of belt of pulley C is acting on the right side downside here. So we just draw back. So we assume that this is pulley C, and then this is the direction of belt TC, and then it says that the angle of pulley C is 60 degrees from the vertical. So let's say this is the vertical, and then the angle of belt TC, pulley C to the vertical here is 60 degrees. So we will use the same step as before for pulley A and pulley C. First, we will try to find what is the total torque acting at pulley C. So we know that power for pulley C from this table is 3.4 kilowatt. 3.4 kilowatt. And then the speed of pulley C we can see is 300 revolution per minute. Okay, revolution per minute. So we can find from power, which is power is equal to d omega. So we arrange back. So TC is equal to P power at pulley C divided by speed of C, pulley C. So 3.4 power of 3, and then 2 times with pi, and then the speed of the pulley C is 300 divided by 60 to change into the second. So we will get the value of TC torque at pulley C is around 108.225 Newton meter. So this is the value of total torque or torque acting at pulley C. So from this torque at pulley C, we can find what is the value of F1, let's say, for tight side, and value for slack side. Also, we will use the given information here, which is the belt tension ratio for pulley. So let's say F1 is the tight side, so for slack side is equal to 2F2. Okay. So F1 is for the tight side, F2 is for the slack side. So if using the tension belt ratio is 2, so F1 will become is equal to 2F2. So this is the number 1 equation. And then number 2 equation, we will use torque is equal to Fr. So torque at pulley C is equal to F1 tight side minus F2 slack side times with radius for pulley C. So this is will become the equation number 2. So if using this equation, so TC is 108.225 is equal to F1 minus F2 times with the radius for pulley C is the diameter of pulley C is 350 times with -3 to convert to meter, and then divided by 2 to to find the value for radius, and then f1 here we will change into this one, f2. So 108 225 is equal to 2f2 minus f2, 350 power negative 3 divided by 2. So when we solve for force 2, it will, so f2 you will get 0.618 kilonewton. So this is the value for slack side for pulley C. Then we put this value f2 into the first equation. We will get f1 is equal to 2 times with 0.618 kilo. So f1 is equal to 1.236 kilonewton. Alright, so we have the tight side value here, and we have the slack side value here. So this value we will put on this side and on this side to find what is the total force acting at pulley C. So the total force acting at pulley C is equal to, total force acting at pulley C is equal to F1 plus F2. So Fc is equal to 1.854 kilonewton. So this is the force, total force acting at pulley C, which is the total force is 1.854 kilonewton. But this force have angle, which is from the vertical x 60 degree, means that the value of force at pulley C, this one, we need to resolve into x and y component. So we will resolve. So this one is 1.854 kilo times with sine 60, and then for the vertical is 1.854 kilo times with cos 60. So you will get the value. So for x-axis 1.854 times sine 60, you will get around 1605.61 kilonewton. And for the vertical one, you will get around 927 Newton. So again, what is this value represent? So this value will represent the force acting on the shaft. So this is also not kilonewton but only Newton. So now we have managed to find what is the force acting at pulley C with respect to x-axis and with respect to y-axis, because the final total force have angle. So from this angle we need to resolve into x and y component. So for x-axis, the direction of the force that we have resolved into x-axis is to the right side. So if the right side means that it has the positive sign, so it will acting on upwards for x-axis because the force is acting on the right side, so it will become positive. And then the value is 1605.61 kilonewton. And then for this value here, for the y-axis, we know that the force is acting on downwards vertical, so it will become negative. And then the value is So this is 927 Newton. Sorry, this is not kilonewton but Newton. Okay. So now we have the last pulley that we need to find is the pulley D. And if you see from this diagram, for pulley D, the direction of belt is only on the x-axis. Means that the force acting at pulley D only have in terms of x-axis, but in terms of y-axis, there will no force acting at pulley D, because for pulley D, the direction of belt is only in terms of x-axis. There is no force acting for y-axis for pulley D. So for pulley D, in terms of y-axis, it will become 0, but for pulley D, for x-axis, they will have value here. So we will find what is the value. So this is we have an error here. This is not kilonewton but only Newton, and this is also not kilonewton but Newton. So now we will solve for pulley D. So for pulley D, if we see the direction of belt for pulley D is horizontal onto the right side. So we just draw for our standing here. So this is TD, and then this is TD. So we will find what is the total force acting on pulley D. But in order to find what is the total force acting on pulley D, we need to find first what is the value of torque acting on pulley D. So given that power for pulley D is 6 kilowatt, so 6 kilowatt, and then the speed of pulley D is 500 revolution per minute. So we can find what is the value of total torque happen at pulley D. So P is equal to T omega. So we arrange back. So TD is equal to PD WD, which is the speed. So PD is 6 kilowatt divided by 2 pi, and then the speed is 500 divided by 60 to convert to second. So we get the value of torque at pulley D is around 114.591 Newton. So this is the value of torque at pulley D. So now we have the value of torque at pulley D. You can find what is the value of F1 here and the value of F2. Value F1 for the belt on the tight side. F2 is the value of slack side for belt for pulley D. Also, we will use the hint here because of the belt tension ratio. So if the belt tension ratio is 2, means that F1, the tight side, is equal to 2F2 for the slack side. So this is the first equation, and then the second equation comes from the torque is equal to F times with R. So torque for pulley D is equal to F1 tight side minus F2 slack side divided by RD times with RD. So this is the equation number 2. So now we put value of TD here, and then F1 we change into this. So TD is 114.1591 is equal to F2 after we have changed minus F2, and then the radius of pulley D is 450 millimeter. Convert to meter divided by 2 to get into the radius. So F2 we will get 0.509 kilonewton, and then this value F2 here we will put into this value f2, put into this, so we get the value of f1 is equal to 2 times with 0.509 kilo, and then we get f1 is equal to 1.01 at kilo Newton. So basically we have managed to find what is the tight side, this one, and then what is the value f2, the slack side. So now the total force acting at pulley D is equal to, let's say FD is equal to F1 plus with F2. So FD will become around 1.527 kilonewton. So saya tulis balik kat sini. So FD is equal to 1.527 kilonewton. So again, untuk apa value FD ni? So this value FD we will put into the free body diagram of the shaft in terms of x and y axis. So if we see here, the total force acting at pulley D is only on the x axis. There is no force acting on the y axis. Means that for the free body diagram in terms of y axis, the D value will be 0, but in terms of x axis there will be a value of pulley D which is acting on the right side, so it will become positive. Positive means that for x axis it will become it will acting on the upright, and then the value is 1.527 kilonewton. So for y axis there is no force acting on the y, so for pulley D, point D, it will become 0. But for x axis we have a force acting on the right side, so right side means that the force will acting upward with the value of 1.527 kilonewton. So basically this is our free body diagram for shaft in terms of x-axis and shaft in terms of y-axis. So if I draw back for x-axis, so for point A there is no force for x-axis, and then at point 1 there is a bearing. So bearing, usually we will assume there is a reaction for bearing 1, and then at point B we have force acting downwards, point B, which is 3129.18 Newton. And then for point C we have force acting upwards, 1,605,601. And then for point number 2 we have bearing, so this is R1 and R2 represent support for bearing. And then also at point D there is a force acting upwards with the value of 1.527 Newton. This is for x-axis, and then for y-axis, if I draw back, so at point A we have a lot here, 2, 3 at 2 Newton. And then for point 1 we assume there is a reaction force in terms of bearing upwards, and then at point B there is a force acting on downwards, which is 1, 1, 3 at 0.93. And then for point C, also there is a force acting downwards with a value of 927 Newton. This is Newton. And then at point 2 there is a bearing, so we assume there is a R2 bearing here acting upwards. And then at point D there is no force acting on it. So now after you manage to find all the loading comes from the pulley A, pulley B, pulley C, pulley D for x-axis, and loading from pulley A, pulley B, pulley C, pulley D for y-axis, you need to find what is the reaction force. So you need to find the reaction force R1, R2, and then R1 for y-axis and R2 for also for y-axis. So after you manage to find what is the R1 and R2 for x-axis, R1 and R2 for y-axis, you can proceed with your shear force bending moment diagram, shear force diagram and bending moment diagram. Okay, so your task for another 1 hour of our class today, I want you to solve the question to draw the shear force diagram and the bending moment diagram, and to find what is the diameter of the shaft. So that's all. Thank you.